Hello there, it's Jay here from Jay's Vintage Junk, and if you haven't guessed already, we're back on with the French HMV record player. Now I'm going to refer to it as the French HMV record player for the simple fact I'm having serious trouble pronouncing La Voix de son maître. Actually, that's not too bad, La Voix de son maître, which is HMV in French, or his master's voice in French. Right. My mate Steve came and paid me a visit the other day, and he brought me this. So we have potentially a replacement mains transformer for this. I thought I actually had one that would be suitable, that came out of an old, I think it was out of an old TV signal generator or something like that. Unfortunately, when I checked it, the heater winding is open on it, so it's not of much use for this project. It may come in for other projects in the future because the HT side of it is fine. It's just the filament winding's bad on it. This one should be absolutely perfect for this. We have a look. This is this isn't an old transformer. This is new manufacture, made in Great Britain, and it is a more modern style transformer. But it's got everything we need on here. We've got a 0 120 volt tap and a 0 120 volt tap. So if we go across the 220 volt taps like that, we've got a 240 volt input. On the outputs, we've got a, on the secondaries, sorry, we've got a 2 amp winding at 6.3 volts for the heaters. And then we have an 80 milliamp winding, which is 190 volts, centre tap and 190 volts. So we'll get, what, about 300 and odd volts, 380 volts or something off those, or 190 volts off there, which is probably all we'll need for this. 190 volt rectified will give us 220, something like that, after we've smoothed it and everything, which should be more than enough for this actual record player. But before I just go to the trouble and just bang that in and see if it works, what I thought we'd do is actually see if the amplifier is actually going to work. I mean, we could have a bad output transformer there. To be honest, if the output transformer is bad on this, we're starting to get to the point of, is it worth doing anything with? Well, it would be the fact that I have got replacements for that. I have got, you know, salvaged output transformers which are suitable for an EL84, so we could just sub that in. And I do like this record player. It is kind of stylish. It is kind of nice. But anyway, before we fit that, we're going to power this amplifier up and actually see whether it's going to work and amplify. And the way we're going to do that, now this is a bloody heavy piece of kit, but I will, oh god, it's dirty as well. Could have done with a clean before I started doing this video. Oh, bloody hell, come on, there we go. Ooh. In fact, I'm going to have to move the amplifier just to get this piece of kit in on my workbench. Right. This wee beast is how we are going to... let me see if I can just adjust this shot a little bit. Sorry about that. I'll get you up to see this thing. Right. This is a Solitron Varipack. Basically, everyone's aware of a variable bench power supply. This is a variable bench power supply for valve stuff. This is actually ex-military. This is ex-MOD. You can actually tell by that little arrow on the front there, which is an MOD kind of symbol. This is a Varipack type SRS 135S. I picked this up at a car boot sale a few years ago for not very much money. It was broken, obviously. I managed to repair it. There wasn't actually that much wrong with it. These are very, very, very sought after pieces of equipment if you're into this hobby. this is like battleship kind of quality gear. I love ex-military equipment, service equipment, you know, meters, things like that. They are always of the absolute highest quality, especially, I mean, this is from, I think it's either very, very late 1950s or very early 1960s. So, you know, it's got some serious age to it already. But what this will do, this will give us a 6.3 volt heater winding. Again, centre taps. We've got 3.15 volts, a centre tap and 3.15 volts. If we go across those two there, we've got 6.3 volts, which is what we need for our filaments. But this will also produce our HT. So we've got our filament voltage there. This side is our HT voltage, obviously variable. And this can give you any HT from 0 up to 600 volts. So at 100 milliamps. So it's basically good enough to run up a lot of valve type equipment without the mains transformer. This will basically substitute for the mains transformer there and the rectifier and the smoothing. So all we're really testing is the actual amplifier section here. We're not actually testing anything to do with the power supply. We're basically eliminating that and substituting it with this thing here. What I'm going to do first, I'm actually going to get rid of the let's get you down a little bit so you can kind of see what I'm doing. I'm going to eliminate everything that we don't want from here because we are going to be replacing it all. So we'll tip this back over. I mean, I will change probably all of these capacitors. I will certainly be changing these because I've worked on French stuff before. I am familiar with these capacitors and they're every bit as leaky as an old wax paper or the Hunt's mould seals. These are just the French version of them. Like I said, they go just as leaky. The electrolytics, we know that one's bad because it spewed its guts all over the rectifier valve socket there. These we're not sure about yet. They'll probably get changed out, to be honest, because I mean they're old. This is like nearly 70 years old. Incidentally, this record player, I have managed to find a little bit of information about it on radiomuseum.org. Sadly, I couldn't find a circuit diagram. There wasn't a circuit diagram available, but at least there was some information on it. So I now know what the mystery valve is. The mystery valve is a EF41. So it's not really an amplifier valve, but I've seen it used many times in record players as like the preamplifier. So yeah, we've got EF41 there. The other two valves, obviously, we know. We've got an EZ80 rectifier and we've got an EL84 output valve. Right, now where is it? So basically what we are going to do at the moment is we're going to get rid of the bad transformer. Pull the wire in, we can cut that. Because we won't be reusing this mains cable, obviously. That'll make some nice test leads or a lead for a test speaker or something. That's what I basically use these cables for. So that can go in my scrap cable box. And all we really want to do is identify which are our heater windings, which is our HT windings, and that's our output there. On that capacitor there, we've got a red wire coming off, which is that wire there, and that is obviously our HT over to the rest of the circuit. So what we can do, we'll get that out of the way. So that's basically HT there and there are HT winding, those two blue wires. And then we've got a black and a brown, which are hidden underneath that capacitor. There's one there and there's one there. There are our heater windings. So what I think we might do actually, let's get those disconnected. I'll desolder them rather than cut them because we don't know how long we're going to need them. So there are HT. And then we've got a heater winding. In fact, let me cut that capacitor out of the way, so we know where it goes. We know it goes to there, and the other end will go to ground, I'm guessing. It goes to ground through a resistor. A burnt out resistor by the look of it. Yeah, there's a smoked resistor in there. With the ground of that going through it, so we'll need to address that, but we don't need to address that at the moment because, like I said, we're powering it up with our own HT power supply. So I will snip that and pull it out of the way. I'll leave it connected up for now, but like I said, obviously it's not in circuit really. In fact, I could cut, because we've still got the metal tabs, so we know where it goes. Eugh. Yeah, it really has spewed its guts, that thing, look. It's a while since I've seen one puke its guts quite as bad as that. Then again, if it, someone like, what I suspect happened to this thing is someone was messing with the voltage selector on the turntable, set it to 115 volts and plugged the thing in and basically fried it. Right, now let's get the rest of these wires off here and then we can pull that transformer out, because like I said, we don't need it. We've got a centre tap to ground there as well. That goes to ground there. Let's pull that off. Okay, so those two are the heater windings, so that's HT there. Let's have a look where you go. That's our switch winding, that's for the switch there. And it's got that capacitor across it. Right, okay. We can disconnect that then. We don't need that there for now. We're not bothered about the switch at the moment, so we can do all the switching using the power supply that we're going to sub in. We'll have to rewire all this anyway, because we'll be putting a new mains cable on it with an earth and correct brown and blue colour codes. So let's get that just disconnected for now. There we go. I'll get that off there. Incidentally, when I rebuild this, I will not be reusing that voltage selector on the turntable, even though I could do with this transformer, because it has the separate two 120 volt tap-ins there. I could actually wire this transformer the same as this transformer here, so it would actually work in that configuration. I'm not actually going to do that, for the very simple fact that if I do that, the same thing could happen to this record player again. We're in a country where our mains voltage is 230 volts. Well, it's actually 240 volts, but we're told it's 230 volts. It's usually closer to 240, as it always has been in the UK. It was all to do with EU regs, that. But anyway, as we are, you know, a high over 200 volts on our mains here, there is no point really having that 110 volt or 115 volt tapping. So I'm going to eliminate it and eliminate the chance of someone burning the new transformer out in the future. Right, okay. So that's the old transformer pretty much disconnected. Absolutely stinks as well. I think it's that electrolyte there as I've warmed up round. I'm going to actually pull the transformer completely out of the if I can get these to turn. I'm going to pull the transformer out of the chassis. It's a big heavy lump that's no longer there, which we don't need. and I'm curious to see how well the new transformer is actually going to fit in there. Dear me, these are tricky. Oh, they're like double bolts. Rather than being like a nut and a bolt going through, they've like got a nut. It's like a stud with a nut on each end. Trust the French to do things a bit different. Okay, that's the first one out. You might want to fast forward through me faffing with this thing. That's the great thing with YouTube. You've got that fast forward feature where you can put people on like double speed when you want to get through something that's a bit tedious and get back to the video without actually just jumping forwards. I do like that feature with eBay. Okay, that's that one out. Pull them studs out. You see what I mean? Rather than using a screw like that, they're using a metal stud with a nut on each end. Got 2 more to go, and then we can hopefully pull this this old transformer out of the chassis. Let's see how they've done this one. I think they've soldered this one. Dear me. There we are. In fact, what I should be doing, actually thinking about it, if I'm being sensible, because this is a valve-based piece of equipment, I should have that plugged in, warming up while I'm doing this, and then it can have stabilised by the time we need to use it. So I will plug that in now and switch it on. Make sure that that's down. That's on, volts, right, that can be warming up. And we'll finish off getting these screws out, well, these nuts off, and we can get this transformer out of here. Last. There we go, that's turning now. And there we go, that's the bad transformer removed. It's like one of these transformers that's not actually held together. That actually might be repairable. There's a possibility depending on how bad it's burnt out, because this is one of them ones where the whole laminations aren't fixed together. I can actually dismantle this transformer completely and pull the bobbin out, unwind it and see what's wrong with it. I mean, it's a lot of effort. It'll be thrown in a box with bad on it, and then if I need something in the future it might get looked at. We'll pull them out of the way, and that'll be kept, like I said, in a scrap box just in case, because them transformers are quite nice. Right, what I want to see now though, I've got the new one. I'll pop these fixings off it and we'll see how well it actually just fits. I've just noticed that the plate's actually drilled for 2 different styles of transformer. I don't think we're going to get that lucky that it'll fit straight off, but we'll have a look how far off it's going to be anyway. The hole's definitely fine, the actual cutout should be fine. It's more the placing of those get that out of the way. Come on, out you come. There we go. Right, now let's see. Oh, look at that. That's going to go in there, lovely. No, unfortunately, no, as I thought, the screw holes are not going to line up, so what I will have to do is re-drill the plate to mount this transformer in there. But hole wise and everything, that's no biggie, that's no big deal. I can easily just re-drill those out when we actually come to fit this transformer, but that's going to fit in there absolutely spot on. We'll just put this back together with a few screws so we don't mess it up, but that is going to fit perfectly, and I'm pretty sure voltage wise we should be pretty much there. We can always play with a few resistance values to dial that in anyway. Unless you're going with a really hot tube, most of these, and at the power we're going to be running at, are very similar, you know. EL84, ECL, or ECL82, anything like that really. They're very, very similar HT wise. There's a lot you can get away with. Put that in there. Put that on there. Right, get that on there, and then we'll start looking at firing this thing up. Right, we're going to need some valves, aren't we? But all we're going to need is the I just said what, EF41. Went out of my mind then. Put the EF41 in, and we want our output valve, which is our EL84. Put its little retainer on to keep it happy. So we don't need to put the rectifier in because that's what we're using this for. We'll get this in a position where we can get to everything and it's happy. Should be okay like that. Right, yeah, because we can get to the speaker wires, we can get to the audio input, and that's really all we need to be able to get to. I'll have to perhaps put it there so I can get to the control on the variable power supply. Right, we need a speaker to try it with. I've just got my, a modern test speaker here. It will do, again, it will do for testing. It's not really as efficient as the old speakers, and it won't work really well with this amplifier, but it'll be good enough for testing. With these valve amplifiers, especially like these little single-ended valve amplifiers like this, to get the best out of them you need a really nice efficient speaker, which these modern speakers aren't. We'll wire it up because, like I say, it will give us enough indication that everything else is happy and working. Strip these off. like that. And we'll just twist this. I need to order some crocodile clips so I can put some croc clips on the end of things like this. It can make life a bit easier, a bit better. Right, so we've got our speaker connected up to it. We'll leave the output just dangling there for the moment. We need some more cables. Now what have I done with them there? What have I done with them? I'm sure I've got them all out ready before I started this. I'll put them in the drawer. Okie dokie. First cable. This is a heavier duty cable. This is what I'm going to use for the valve filaments. So basically what we do, we connect that into there, we connect that into there, and then we've got 6.3 volts AC on those two plugs there at 3 amps. And we're going to connect that to the valve heaters. Now, we can probably use, they're pretty grim with where that in fact we can go right onto them, can't we, because those are what we brought straight off the transformer, those two wires. So that's basically our filaments. So if I connect that to there like that, get that on there, I connect, oh there we go, give you an idea, that actually brought the indicator bulb on as well. So we know the indicator bulb works. Are we getting illumination of the filaments though? Let's bring that over. And yes, both our valve filaments are lighting, so we know that that's working. Next thing we need is some high tension, some HT. So I've got another cable here. And what we're going to do now, this is actually a really thin gauge wire. I wouldn't use this for the heater filaments because there's a chance to burn it up, but it is also rated at about 1000 volts. So this is much better for the 200 or so volts we're going to be doing on the high tension side, and we've got proper insulated clips and everything. So this is what we're going to use this. So we'll go to HT plus on there, HT minus there. Now I've got this turned down so we haven't really got any voltage on them yet, but what we will do, we'll connect one side to ground, which is basically the chassis. So let's find a nice safe place to do that. We can't use that wire there because that resistor's burnt out. Can we use, yeah, that'd work well. We'll use the clip for the filament lamp. Perhaps we just shorted that out then. What else? Well, where else could I get a good... What I basically need is a good ground connection. Where would be a good ground connection? Possibly go off the ground off that capacitor there, because that should work. Again, we can't use that ground because it went through a resistor and that resistor's open. We still need to look at that. But we can go onto there, I think, because that is connected straight to ground. Make sure we don't, in fact we'll go right onto the end of that capacitor there, because that goes straight to ground. We've got our HT there. That we will connect to the red wire there, because that's our HT. Okay, provided that's making a good contact. In fact, where else does that go? See if we can find a better... In fact, what we'll do, because that's a bit of a dodgy contact there, we'll actually go to the other side of this capacitor, because that is where the other side of that wire basically goes. It goes down there. Oh, it goes to that. it goes through that, but we can connect to there. That's the same thing as connecting over there. It's just a better connection. Right. So we've got our HT connected. We'll turn the volume up a bit. Our filaments are already nice and glowing. Our dial light's on because we've got our heater voltage there. And all I need to do now to see if this thing's going to do anything is very slowly. And I will just, rather than crank it right up, because we don't know what state these capacitors is in. And even though we're going to replace them, I don't want them to just short and pull the voltage down. But we'll slowly start bringing a bit of voltage in. Right, we're at about 160 volts there or so. 150, 160 volts. And I can actually hear a very faint buzz from the speaker. Now, this amplifier is working. Can you hear that? All I'm doing is touching my screwdriver onto the lead on the that will go to the phono cartridge, and we can hear there. We've got a very scratchy volume control, but even with all the leaky capacitors in there, we do actually have a working amplifier. Very scratchy volume control, but it is actually working. What I will do, I'll just try giving it a little bit more HT. Right, we've got about 190 volts HT there. Actually, I don't want to push it too much because I don't know what state that capacitor there is in. That's the only high voltage capacitor left in, well, high voltage electrolytic capacitor. All these could be leaky, which they probably, like I said, they most likely are. So we won't run it for too long like this, but we've got a fairly decent amount of volume there actually. That's not bad. What I think I'll do is we'll try and actually play some audio through it and see what it sounds like, see what the with the tone control actually operates and everything like that. So I'm just going to quickly pause you while I get a few other little bits and bats out, and then we'll be right back. Right, we're back. As you can see, I've just done a quick reset of the camera so you can see the laptop. What we're going to do, I've got some royalty-free music set up on the laptop. This is Feel Lilumigidi, I think, or something. What I'll do, because this is copyright free music and it's only fair, I will leave a link in my description to this video down to the royalty free music that I'm actually using. Like I say, easiest thing when you're doing videos like this and whatever, and you need some music to play while you're demonstrating stuff, just go on YouTube and type in royalty free music. And generally speaking, providing you actually credit the person that's actually produced the music, like I said, I will leave a description, I will leave a link to the music that I used in my description. That's all you really need to do, and there's no issues with copyright. Obviously it's not as easy if you're trying to play a record, that's where we all come unstuck, but if you just want to like demonstrate an amplifier or something, this is about the best way you can do it and not get hit with the YouTube copyright police. Anyway, I will show you basically what we're going to do here. What we're not going to do, because we don't know the full state of this amplifier yet, is just connect my laptop straight up to the amplifier, because we've got leaky capacitors and all sorts in here. We could have the situation where, you know, we put a couple of 100 volts through the audio connector on my laptop, and that wouldn't be good, because that's about the best laptop that I've got. It's i3 processor in it. It's actually not too bad. It certainly works as my workshop laptop anyway. So what we're going to do is, this is how we're going to connect that to that. And it's actually using some junk, which is my way of doing most things. What I have made is this. Now what we've got is we've got a 3.5mm jack there. We've got some phono connectors on there, and they're wired for mono. They're just wired together, so it doesn't matter which one of them I plug into, it's mono. And what we've got in the middle, that there, that is actually the mains isolation transformer off a old scrap Skyboard. In fact, if you watched that video I did a couple of videos back when I was showing reclaiming components off scrap modern boards and multi-layer boards, I actually took it off that board. Like I said, this is just the mains isolation transformer, and they work excellently as a audio isolation transformer, and that's basically all we're doing here. So we've got a 1-to-1 ratio transformer there with one winding connected to our audio input, the other winding connected to those phonos there. So there is absolutely no physical connection between the two devices. It's all isolated by that. You can buy proper audio isolation transformers, but for something as low fidelity of this, to be honest, you can get away with these. These work fine, and they're free. You know, any Skybox, well, any switch mode power supply that's worth its salt will have one of those in it, and generally speaking they all seem to work absolutely fine for audio, for doing things like this, for isolating an audio signal from something which potentially could have a high potential on it. So we've got that, and then I've got a phono there, a couple of crock leads on the end of it. So what we'll do, that connects to either of those like that. That goes into my laptop, and we can connect these. That's ground there, and that's our signal wire there from the phono cartridge. So that's connected up. We'll start the laptop playing some music. I will set the volume probably about halfway, about there. We've got some music playing there. Come on, laptop. Why is the laptop not wanting to play? Come on, laptop, play. There we go. That's working. So we've got definitely got audio playing on the laptop. I will wind up the HT. So there, we've got about 200 volts on the HT there. Obviously, because we've got a very crackly volume control, and a not very efficient speaker. But we are proving that the whole amplifier is actually working quite nicely. And try a little bit more HT, but I don't want to go mad. About 220 is probably about where we want to be on the HT, 200 to 220. We'll try the tone. Even the tone control actually does work. So we've got very scratchy controls, but that's by the by really. So that does seem to work quite nicely at that. So yeah, we're going to be probably looking around about the 220-ish mark on our HT. We can check all that basically when we start rebuilding. Obviously we've probably got a lot of leakage in here with them bag capacitors and things like that, so we're not wanting to be too critical on it at the moment until we actually fully recap and rebuild this amplifier. But what we have proved is our valves are running. They mightn't be in full health, but they're at least got some emission to them. Our output transformer is good, and the circuit itself is basically okay. even if it has got a few components which need replacing. We'll turn that off there now, and we will kill the HT. Well, we'll kill HT and LT. We'll switch the power supply off, and yeah, I'm actually quite pleased with that. So we've proven that even though the mains transformer has met its maker, the rest of the amplifier has survived fine. The valves work, because that was one slight concern I had, was has it killed the valves? Because obviously if you think about it, if it was expecting 115 volts on the input and it got 230 volts on the input, the way a transformer works, the ratio of what voltage is on the input is proportional to what's on the output. So we've probably got, instead of 6.3 volts, until that winding went open circuit, we could have had like 12 volts or so on them heaters on them on that valve, which obviously potentially could kill the valve. It looks like we've got away with it, and at least the output valve and the preamplifier valve seem to be okay. Obviously we've not tested the rectifier valve yet, but I'm guessing if they've survived, that's probably survived as well. Anyway, I'm going to leave it there for this video. Like I said, all I really wanted to do on this video was just see whether the actual amplifier had any signs of life in it, which it does, and see how hard it was going to be to put that replacement transformer in there, which, to be honest, is going to be quite easy to do. All we're going to have to do is re-drill the chassis plate there to take the new fixings, and then that transformer will drop straight in there. And then it's just a case of really doing some recapping work, replace some of the capacitors down there. Like I say, I know we've got a resistor up there that needs replacing. That's burnt. It's actually burnt open. And that, obviously clean this electrolyte that's spewed its guts all over the bottom of the rectifier valve there. A little bit of a tidy up, and I think the amplifier should be happy. I'm quite pleased with that. It's a nice little amplifier, really. Once that's done and we've got all that back in the cabinet, then we can turn our attention to that and see if we can get that working. If we can't get that working, I'm still pursuing this project. I can't see there's any real reasons why we shouldn't be able to get this happy and working. But if we can't, what I'll probably end up doing is cutting a motorboard this size, fitting that in the case, and then fitting a model, like a BSR UA8, or it's got to be something mid to late 1950s. This record player I think came out in 1956 from what I could find out. So something, British but period correct, and I put something like that in it because the cabinet is really, really nice. I hope I can actually do something with this turntable. It's all being down to whether I can replace some of those rubber bits on the back which have perished and fallen to pieces, and the fact that if this was a BSR, a Garrett, a Claro or something, I know I'd be able to get parts for it, even though there's none available now. I've got Andy over only a few miles away from me that's got a stock of plenty of record player parts. I have quite a lot myself. It's usually not an issue to source a part for one of these turntables. In this case, however, I've never seen one of these before. I've never worked on one of these before, and they are not a record player, which is really... I don't know whether these were ever sold in the UK. I know it's an American design, and obviously they were sold on the continent, but I might struggle to get bits and parts and bushings and things for this in the UK. But I won't give up on it. Like I said, my main thing is to see if we can get this deck working and keep the originality. I'm going to have to change those two capacitors, which are the motor start capacitors. We've also got to figure out how on earth this thing is wired as well. I have a feeling that this might actually be a 115 volt motor. And yet all the rubber that holds that in place has gone. I've just looked here, there should be rubber bushings on all of these. They've all gone, they've completely rotted away, there's nothing left of them. That one we discovered the other day, was it over here? Yeah, the bushings completely, rubber is completely gone on it. But looking how this is wired, I have a feeling this might be a 110 volt motor. And they're using the other secondary or something. They've wired it somewhere with that transformer, so even if you've got 230 volts, 240 volts coming in here, the motor's probably still running at 110, 115 volts. We can still do that with the new transformer because of the way that the primary is wired. We could probably take a tapping off and run it like that. But that's concerning me. I'll have to do something about that, because it's not going to play with that amount of, you know, that should be on rubber bushings and be very hard to move. So yeah, that's a project in itself. But before we even look at that, like I said, we'll get this amplifier all finished off and back in the cabinet, and then we'll decide what we need to do, whether we can get that turntable working or put something that I'm a little bit more familiar in there. So anyway, I'm going to leave it there for now. I hope you enjoyed the little update on this project, so I will say thanks for watching and goodbye.